Hi everyone, I'm Naama from Outbrain, and I'm here today together with my colleague Alex. We are going to talk to you about how we manage to increase our data science velocity with an internal platform called Model Manager. We are going to walk you through the process of developing this platform, starting with Outbrain's AutoML, discuss what does it take to take a model to production, some of our architectural details. Alex is then going to demonstrate the actual model manager and the implementation details, and just to conclude with some of the things we learned during the process. So let's take a look at Outbrain's AutoML. I'm sure that at least some of you are familiar with this concept. And at Outbrain, we have our own AutoML, which we internally developed. At its core, we have our data pipeline. We keep our data in Hive, and we have AutoML components to download, convert, and transform raw data into a feature data set that our machine learning model can learn on. If you look on the left of this diagram, you will see the research platform. Our offline research platform is all about evaluating and training models at scale. When a data scientist is starting his offline research, he usually is working with a fixed data set and is comparing his models using a non-business metrics such as a RIG or AOC. And by the time he completed his research, he usually has a couple of model candidates to take to A/B tests. A/B tests run in production, of course, so you can see on the right-hand side of this diagram, our online environment. And our online environment is special in the sense that it also continuously trains models. We use incremental training approach, which means that every couple of minutes, our models fetch new data, train new models, and update them in production. So this means that online environment also uses AutoML components to build and train models continuously. Today, we're discussing taking a model from the offline research on the left-hand side to the production environment on the right-hand side. What does it take to take a model to production? So why is it so complicated to take a model to production? Let's take a look at what we do. First, we build, of course, an artifact, and then the model is going through a bootstrap phase. What is bootstrap? Bootstrap is pre-training of a model, which is usually done on 2 or 3 months of data. And once this is done, we have a model ready for an A/B test. At this point, we need to validate and test the model, which usually involves feature validations, latency tests, extreme predictions, and so on. And when this model is validated, we can assign it to its first initial A/B test. The initial A/B test usually runs with the low amount of traffic. And at this point, we already have business metrics to look at. We have CTR, we have RPM, and we look at it. And if we decide that this A/B test looks promising, we keep increasing the traffic for this A/B test. Again, we look at performance, and when we decide to conclude this A/B test, if it was successful, we replace the model in production. After replacing the model in production, of course, we need to monitor it. So at this point, you can still argue that this is all part of the job, and it doesn't seem that complicated. So I think that first we want to say that this is just basically a waste of time. We want our data scientists to do research. We want them to work on improving models and not just doing day-to-day routine tasks. And then, second, if you remember, I said that our models keep learning in production. This means that the work is not done when we assign a model to production, when the A/B test is done. In production, we need to keep monitor this model. We need to monitor, for example, for feature drifts. We need to make sure there are no extreme predictions, there are no errors while training and updating the new model. So a lot of work to do even when the A/B test is done. And last, we don't only have one model to take care of. We have a lot of data scientists working. Each one has a couple of A/B tests running. We have several use cases in production that use machine learning models. So overall, we have dozens of machine learning models in production that we need to take care of. So hopefully at this point, you agree also that we want to do some automations. And we are at the research infra team at Outbrain. We are actually a team of engineers. Yeah, we can move to the next slide. Thanks. And as engineers, we are very used to the CI/CD approach. CI/CD method is about building, testing, releasing, deploying, and monitoring software in production. As engineers, we are used to platforms like Jenkins and TeamCity. We are used to the concept of unit tests and integration tests, and all of that can be applied to machine learning models. The only problem was that we couldn't find the right platform or third-party product that we can use to integrate our existing AutoML components together with all the internal interfaces we had. So at this point, we started to understand that we want to implement our own infrastructure. We had the motivation, we had the vision, we knew how we see it, and we just needed to start thinking about the architecture and take the initial architectural decision for this platform. So first decision we made, let's jump forward, please, yes. Alex. Yeah, and another one. So first architectural decision we made is to use Airflow as our pipeline engine. The choice of Airflow wasn't that straightforward to begin with. First, just because Airflow was not in use in Outbrain. Outbrain was using a workflow engine. And when we started about 2 years ago, the Airflow API wasn't that user-friendly. And also we knew that we didn't want to expose this UI to our data science users. On the other hand, when we POC'd with Airflow, we found it really easy to integrate our AutoML components. This is all Python-based. We found it very easy to ramp up the initial POC. So overall, eventually, we decided to go with Airflow. And looking back, I think we are really happy with this choice. Also, other teams in Outbrain started to use it. So this was very successful. Other decision we had to make. First, for the backend. Next, please.
Yes.
So our backend is Flask and MySQL, which is, again, very straightforward for Python platform. As for the UI, we really wanted our users to be able to trigger pipelines through Slack. And then, as I said before, we didn't like the Airflow UI. We had some kind of a vision that we want a unified dashboard that will also display business metrics and performance metrics on top of Airflow state and status and all relevant information that is everything that is relevant to the model and to the A/B test. And because of that, we faced the challenge of many internal interfaces. We needed to integrate interfaces to Outbrain Service Cloud, to HDFS, to many of Outbrain's databases to get the relevant metrics and to get the relevant statuses. So a lot of internal APIs needed to integrate into both Airflow pipelines and the visionary dashboard that we had in mind. And now I'll move you through to Alex just to show you the actual implementation. Hey, Alex.
Hi, thank you. So, hi, everybody. My name is Alex. I work with Naama in Outbrain in the research infra team. And now I'm going to show you a bit of a general view of how this process that Naama described looks. The first thing we do, like Naama mentioned, is talk with our Slack bot, which is called Peach, like the princess in the Mario Bros game. And you tell her to deploy a model, right? This is how a model looks in the beginning. It's just a JSON. Normally, it's a bit more complex, but on the one side, it describes hyperparameters of the models, features, a bit of feature engineering, and then metadata for the deployment process, like the model name or where it's going in HDFS. This is kind of like how it looks, and the bot starts giving you updates, right? Validates the input. We're going to go a bit more in depth, but normally this is how it looks for the end user, for data scientists. This is how the actual DAG looks now in Airflow. Also, we're going to go more in depth, but it's my idea with this is that I want to show you that it's a kind of a complex process, that it's all automated. And again, for the end user, it's just attending to some updates in Slack by a bot, right? But there are a lot of steps. I'm also going to simplify a bit, but let's start from input validation, right? We want to check in our feature store that everything is right with the features mentioned in the JSON. We want to check that there are no duplicate models, stuff like this. We want to check format and syntax. We want to check there are no missing important parameters. We want to add all relevant entries to our DBs. Mostly we use MySQL, right? But also Vertica for metrics later on. And then we head into artifact creation. Okay, now the cool part starts, the bootstrap part. Let's go step by step. So like Naama mentioned a bit, let's talk about bootstrap a bit more. Like I mentioned before, the models are only metadata at this point. They're only a JSON, right? So we want to make them into an actual machine learning model. We want to make them into weights. So first of all, we get into a queue. During the bootstrap, like I mentioned, this will the model will start existing via training on several months of past data, or whatever the data scientist decides, 2 weeks, 1 month, 2 months, 3 months of data. And for this, it goes into a queue, which is the dynamic allocation of slots. This is like to better manage our resources across our different DCs, because Bootstrap is heavy calculations and they're heavy processes, so we need a lot of memory and CPUs. And like it's a queue, if the slots are full, the model just waits over there until there's a free slot. Then we create the learning deployment, right? Like I mentioned before, this requires special hardware. And then you start learning. This is the biggest bottleneck we have right now. This like 95% of the time spent in the pipeline is the model bootstrapping, which is training in past data. So training on 2 or 3 months of data can take a couple of days. And then we create our first OLO deployment. What's OLO? Like Naama mentioned before, all our models are online learning, which is a type of incremental learning where you just feed the model the freshest data available, because you have the 2 or 3 latest month of data, and now it gets up to the current date, it arrives, and we need to keep feeding it normal, regular, fresh data, the freshest available. So OLO is online learning orchestrator. It's the solution, our solution for this. This is the next part. We're going to also go into depth a bit, but from the first OLO deployment, we go into the second one. Why? Redundancy. We have a deployment in one data center and we create another one in the other one. So both OLOs, which is our service, are training parallelly. So we need to sync one model to the other DC. The model that was already trained on 3 months of data, we want it in the other DC too, right? Also for the sake of redundancy. So this is an HDFS operation. And then once both of our OLOs are running and everything is okay, and the model is learning and new models are getting uploaded to HDFS, we move that model, we upload it to our serving system. Then we update everything database related. We start reporting metrics. And success, your model is deployed, online learning, and healthy to move into A/B test. Right? This is how it all looks. Another part in the DAG would be, what if I don't want to waste days training in previous data? What if I want to branch out an existing model? We also allow that, right? Let's focus on that just for a minute. So instead of bootstrapping and starting from scratch, you can fork an existing model. So the only thing that requires is doing the copy command in HDFS, right? And this is how now it's complete and everything looks like that. We have another DAG that's A/B test assignment. This is a bit more simple, but basically we want to make sure here that you either assign or unassign. We changed the OLO settings that allow for the online learning model to be available for A/B testing. We update our A/B test systems and our DBs, and we sent it to be A/B tested. And now what I wanted to show you is Model Observatory, which is our front end. How this looks for data scientists. They don't only receive Slack, they not only receive Slack updates, but they can also look here, getting out of the slides for a second. This is the dashboard we also created in-house. So it's a lot of functionality. Basically, you have 5 types of models. The ones that goes to deploy, which I just showed you. You see the step where they are at. Have the production and the staging models, which are relevant to each A/B test, production A/B test and stage A/B test. And we also have pre-assigned and post-assigned models. These are waiting to get assigned to an A/B test and after assignment. How does this look? So for example, this is the prod section. We have lots of different interesting stuff. We have the amount of traffic the model is being served. We have the days it has been assigned, right? This has been here for 50 days. Data days, which is the amount of data the model is trained on. We have the metrics here, which are currently hidden. We have HDFS related stuff. If we want to mention a specific control model for this variant. And we can search, right? I want our deep models, they're over there. I can get all the models that belong to this user here, which I also hid the names, but user 46 only have this model here in production. 34 has a pre-assigned one. That's how it looks. I don't remember which were the most popular, but you get the idea, right? For example, here. And we also have the different types of models, CTR, CVR, use cases. All of those are filters. From here, you can also see the model's history, which is also something interesting. This particular model has started deployment, finished bootstrap, and uploaded to model store. And this is all the A/B test history. So it was assigned and unassigned from stage, then it went assigned to production and assigned to a higher variant with more traffic, again here until it was assigned with the global control. We can also assign a model or unassign through here to a specific A/B test. For example, if I go to a pre-assigned model, I can open a chat and say, I want this use case and I want to assign it to one of these variants. We have more here in paid online, that kind of stuff. And we initialize it here. We can also see which models have, for example, this one that it's highlighted in yellow, it's been unassigned for a long time. So maybe it's time to free our resources, right? So it lets you know, and it also sends an email to the relevant user. And there are also some of these warning stuff, which means that these models are running from a specific branch. And because it's not the master branch, it won't get updated automatically. So the user needs to take care of the specific Git branch for this model. You can also clean your models with this little thing here. I don't dare touching, but the idea is I don't want to clean some other user's model, but you can do it from here too. And that's all in a nutshell. We also have here a small search bar that is used for searching substrings in the model JSONs that I showed you in the beginning. Back to our slideshow. And this is just a small rundown of everything related, all the systems involved here. So you have Model Manager running on Apache Airflow connected to Slack. These are all the APIs we're using. So Redash for graphs, Grafana for also dashboards, Jenkins for builds, HDFS to store our models distributedly, Prometheus for metrics, Hive also as a database, and Elasticsearch for logs, right? And these are all in-house systems and services, the email service, the A/B test framework, Service Cloud, the model serving infra, our databases, MySQL and Vertica, like Hive, and our own API to communicate with our frontend. To give you an idea of how complex this project was. And now back to Nama.
Yeah, so I just want to wrap up with some takeaways, things we learned during developing this. First, may sound trivial, but I think it's not. Good engineering is important to your data science work. A lot of organizations needs to understand that they need to invest in a robust, scalable, dynamic research infrastructure if they want to improve their data science. For us, implementing this really helped first reduce production issues and then just again improve our data science level. We have more A/B tests, we have faster research cycles, we have more data scientists working on the infrastructure. So overall, really improved both the user experience, of course, and the level of data science work that we do at Outbrain. Second is visibility. I think we are used to think of machine learning models as black boxes, but we learned that there are a lot of metrics we can add to a running model just to understand its performance and just to understand where we need to improve. And you really want to put your efforts where they make the most impact. And last is again from the software world, be truly agile. Just start very basic and simple, get your user engaged, get your users to trust your platform, and then you can really understand the next step and what you need to do just to make your platform better. So this is it from us. Thanks for listening. Feel free to reach out in Q&A or in mail, and enjoy the rest of the talks today.
Bye, thank you.
Bye.